Welcome back to the channel, guys. Hope you are doing extremely well, and this is lecture number 12 of the linked list series. So let us have a look at it. We are going to discuss the question: remove duplicates from an unsorted list. Remove duplicates from an unsorted list. So as you can see, the list is 1 2 3 2 1 4 4 6. It is an unsorted list, right? I have to remove duplicates. I have to remove duplicates. Also, I have to keep in mind that I have to keep the first occurrence in my hand. First occurrence. What do I mean by that? So you can see 2 is occurring here, right? 2 is occurring 2 times. So I have to keep the first occurrence in the linked list and I have to preserve the order. That is 1 is occurring here. So I will keep this one. 3 is occurring here only. So I will keep this 3. 4 is occurring here. I will keep the first 4 and I will keep the 6. So my linked list in answer would look something like 1 connected to 2, connected to 3, connected to 4, connected to 6, and this will be my answer linked list. This will be my answer linked list. So like we discussed in the first, like previous video, we have to delete the elements of a particular value. We have to delete duplicates here, right? We have to delete duplicates here. Now how can I do that? So approach 1. Now because I have already discussed the dummy approach with you, I will be using that because it makes my code look very much cleaner, right? So I will say my dummy node is equals to -1 right now. I will take a here. I will take a here. I will keep a temp here. I will keep a temp here. I will start traversing. So I will see temp equals to 1. I will start the traversal and I will see that if 1, that is temp value, is already in my linked list which is starting from dummy, I will see that if this value which is a temp val is already in the linked list which is starting at dummy, right? So what I will do, my approach is for each value in temp, check the whole answer linked list for that value. The condition is if the value is already there. If the value is already there, in that case, if the value is already there, don't add temp. Don't add temp. Else add temp to answer linked list, right? That is pretty obvious, right? What do? You will traverse the whole linked list which is you have in your hand as an answer linked list. You will see if 1 has occurred before, no, then add 1, otherwise go traverse next. Okay, so we already know how to add 1. I will say what were my steps. I will say a is next equals to temp equals to temp next, a equals to a next equals to null. See, I'm not trying you to tell you to cram this. I'm just visualizing it. So what I'm doing is a is next equals to temp. Make this connection. Temp will go here. A will go here, and then break this connection. Why to break this connection? So as to facilitate things at the tail. I will break this connection. My temp will be here. My a will be here, and after that my a will come here, right, for the further addition. Okay, so I will start with it. I will do, like, I will check the whole linked list using a traversal. I will check the whole linked list using a traversal. What is the time complexity in that case? What is the time complexity? So if I am trying to check all the values in the given answer list, it will be O of n squared, somewhat O of n squared in the worst case, right? I want to optimize it. Whether it is phase complexity is O of 1 here, but I do not want that. I want to optimize it also, right? So what will I do? I will do something like keep the elements already inserted somewhere where they are easily accessible, somewhere where they are easily accessible. And the superheroes which come to play in this such scenario are map and set. I can use either of them. I don't need to tell you why. I will just keep the value which I'm adding into the answer linked list in these also, right? And whenever my temp will encounter a new node, I will check whether they are in the map or in the set, and then I can just add them upon their basis. So what will my code look like? I am saying dummy equals to -1. Okay, a equals to dummy, temp equals to head. Now what I will do, I will say while my temp is not equals to null. What will I do? I will say if, let's suppose we use a set, so st dot find temp value is equals to st dot n, that is set does not contain that value. In that case, the four steps, that is a is next equals to temp, temp equals to temp next, a equals to a next, and a next equals to null, a next equals to null. But you will have to do one thing more here. You have to add, before moving temp, you will say st dot insert temp val. Why? For the future purposes, st dot insert temp val, temp value. Otherwise, if that is not the case, that is the element was already there again, so x equals to temp, temp will move forward remaining x behind, temp equals to temp next, and you can delete your x easily, right? At last you will have dummy as your head node, but you want the dummy is next to be head node, so x equals to dummy, and then dummy equals to dummy next, and you can simply delete x, so delete x, and now you will be returning dummy because that is your new head, returning dummy, right? What is the flow right now? What is happening is, so let us take the example of this only, 1 2 3 2 1 4 4 6. So what happens is, let me write down the linked list below. Right, so my first step is to make a dummy node as -1. Dummy is placed here, my a is also placed here, my temp is here. Okay, my set is currently empty, suppose this is my set, right? Okay, I say temp value 1, is it in the set? No, so insert it. Okay, 1 comes here, a is next equals to temp. Okay, a temp equals to temp next, temp comes here, a equals to a next, a comes here, and a is next equals to null, that is delete this connection. Okay, move forward, temp value is present in the set? No, so insert it, and now a next equals to 2, make a connection, temp equals to temp next, temp come here, a comes here, and delete the connection. Alright, moving forward again, temp value not in the set, so insert it, temp comes here, a is next, a comes here, right? And now delete this connection, right? Moving forward, temp value, it is present in the set, so what do? You say x equals to this, temp comes here, delete this node, so it gets deleted. Now moving forward, temp is here, is temp in the one in the set? Yes, temp is in the set. Again, x comes here, temps comes here, and this node gets deleted, so I am just rubbing it. Okay, moving forward, 4, no, 4 is not present in the set, so insert 4, a is next equals to temp, a will come here, temp will come here, and delete this connection. So after deleting this connection, it becomes something like this. Moving forward, temp value already present, x here, temp here, delete your x, so deleting, and it will become something like this, right? Moving forward, temp value not in the set, so add it. Here is your answer, and a comes here, temp is equals to null now, and a is next is already null, so I can just make it null again. Now what you can see, my answer is -1 1 2 3 4 6, as absolutely as I wanted, but just I want to delete this node, so I will say x equals to dummy, dummy equals to dummy next, so dummy comes here, and now delete x. Delete x means this whole get deleted, and I can easily return my dummy. So I will return this node as my head, and 1 2 3 4 6 is my answer. So I hope the question was clear to you, and it's now time for you to see the code of this. So guys, I was not able to find the lead code link for it. There is a question on the lead code, but that is under subscription, so I don't have the lead code subscription right now. So if you have, you can also try it on the lead code as well, but I'm using GFG platform to show you the code for this one. Okay, so first is node star dummy equals to new node with data equals to -1. You can insert any data you want. Now moving forward, I will make a set of int, and let us name it as st. Make an unordered set to reduce the inserting and finding time complexity. So unordered set. Now node star a equals to dummy. Now node star temp equals to head for traversals. Now what will happen? While temp is not equals to null, in that case, if st dot find temps val, if st dot find temps val is equals to st dot end, in that case I will have to add the node. So a is next equals to temp, st.insert temp. That is a very crucial step, because for the future references I want to know which nodes have already been inserted. st.insert temp 12. Now temp equals to temp next, move forward for the traversal, and similarly a equals to a next for the insertion purposes, and now a next equals to null, right? This will facilitate my tail preparations. Now else if that is not the case, if the value is already present in the set, nothing, just delete the node. So node star x is equals to temp, is it will be equals to temp, temp move forward, that is temp equals to temp next, delete x, and now you are free to go. At last you will just have to delete the starting node of the dummy. So node star x equals to dummy, dummy equals to dummy next, delete x to free the memory, and now you can return dummy as your answer. Let us try to compile and run it. Hope it will work fine. Hope I have not committed any error. There is an error. Why is there? Oh, temp val. It is GFG, so it will be temp data. There is a slight difference between the temp value and data in the case of lead code and GFG. It is also what do we say, node and list node. Okay, temp val, again I have done something. Okay, temp data it is. Temp data. Let us try to compile and run it now. It should run fine now, and it is running, taking a time. Oh, it is running fine. Let us try to submit as well. Hope it will work soon. Not correct, it will work soon. Okay, it is working, and it is working. Okay, so you can see it is, the rest cases are getting passed. So thank you for watching. We'll meet tomorrow with a new lecture. Till then, stay tuned and keep coding. Okay, have a nice day. Bye.